Hi everyone. Today we're going to learn about a different type of chemical bond, which is called a covalent bond. Now in our previous lesson we learned about a chemical bond called an ionic bond, and today's focus is going to be on a different type of bond which forms just between the nonmetals and other nonmetals on our periodic table. Now, if you remember when we talked about the periodic table, it could be broken up into kind of two categories: the metals, which are to the left of the staircase, and the non-metals, which are to the right of the bold staircase. Now, there is an exception to this rule, which is hydrogen, because if you look at your periodic table, you'll notice that the metals here are located to the left of the staircase, but hydrogen, which is also to the left, happens to be a non-metal. So when we're going to talk about these covalent bonds today, we're really going to focus on just this very small portion of the periodic table, which is your non-metals, with the exception of hydrogen, which is over here on the left, because also these group 8 elements, which are your noble gases, they're nonmetals as well. However, if you recall, they are unreactive, so they don't react with anything on the periodic table. Rather, all other elements on the periodic table try to be like them to have that full valence shell. So we're really only focusing on just those nonmetals that need to complete their valence shells. Now, when we talked about ionic bonds, we talked about how they form due to a transfer of electrons from the metals to the nonmetals. Well, when we talk about covalent bonds, they form from sharing electrons. So they can't both gain valence electrons to satisfy their valence shells. So instead, they're going to share their valence electrons. And again, that's to complete their outer energy level, their valence shell. So looking at a couple of examples here, we're going to start with carbon. Carbon is part of group 4 on our periodic table, which means it has 4 valence electrons. Now I'm going to do a quick draw of carbon's Lewis structure to show that. Okay, and if you look, you'll notice that all 4 of these electrons that are drawn in the Lewis structure don't have a little buddy next to them, so they're considered unpaired electrons. So it has 4 unpaired electrons. Now, since it has 4 unpaired electrons, that's the exact number of bonds that carbon can make. It needs to make 4 bonds in order to complete its valence shell. Now we're going to move on to nitrogen. Nitrogen is right next door to carbon in group 5, which means that nitrogen, when you draw its Lewis structure, would look like this. And it has 5 valence electrons and 3 unpaired electrons. So those unpaired electrons are these right here. These that are by themselves, don't have a little buddy next to them. So it has 3 unpaired electrons, which means that it can only make up to 3 bonds in order to complete its valence shell. And now we're going to go on to oxygen. Oxygen, part of group 6. It has 6 valence electrons. So oxygen, its Lewis structure would look like this. And it has 2 unpaired electrons, so it can only make 2 bonds. Fluorine is part of group 7 on our periodic table, so it can has 7 valence electrons. And if you look at its Lewis structure, it looks like this. And it only has 1 unpaired electron, meaning it can only make 1 bond. And hydrogen, the exception. It's to the left of the staircase, but it is considered a nonmetal. And it has 1 valence electron since it's part of group 1. So its Lewis structure would look like that. 1 unpaired electron, so it can only make 1 bond. Now you may be wondering, well, if it wants to have 8 valence electrons to complete its outer shell, why can it only make 1 bond? Well, hydrogen only has 1 electron in that valence shell. And remember that the first energy level can only hold 1 electron. So if we were to draw the Bohr model, it can hold 2 electrons. If we wanted to show this with the Bohr model, it would have 1 proton, has no neutrons, so there's the nucleus, and then its first energy level, remember, is full only when it has 2. So really, hydrogen only wants to make 1 bond in order to fill its valence shell, so that it could be more like helium here. Okay, so it only makes 1 bond. All right, so we're going to practice this just like we did with our ionic bonds. We're going to start off with fluorine, bonding with fluorine. So if we look back at our table up here, fluorine Lewis structure, part of group 7, has 7 valence electrons. So its Lewis structure would look like that. And it's going to bond with another atom of fluorine. Okay. And again, you'll notice that we have 2 electrons here that are unpaired. And so they form a bond in this area. So those 2 electrons are going to pair up because they're by themselves. They don't have a little buddy. And so these 2 atoms are sharing 1 pair of electrons. So 2 atoms sharing 1 pair of electrons is considered what we call a single bond. So what would this look like for the structural formula? So the structural formula just shows where that bond is being made. You don't show those paired electrons, the ones that already have a buddy. So you just draw a line to represent the bond that has formed between those 2 atoms only. So the chemical formula for this, right, when we're representing chemical formulas, you're just talking about how many atoms are participating in the bond. So here we have 2 fluorine atoms, right, 1, 2. So the chemical formula for this would just be F2. And the type of bond that has formed, like I said, is called a single bond. Now, the reason why it's called a single bond is because here we have 2 atoms and they're sharing 1 pair of electrons. The key here is this 1. They're sharing 1 pair of electrons, and that's why it's considered a single bond. So moving on to the next example here, now we have hydrogen and oxygen. So hydrogen has 1 valence electron. Oxygen is part of group 6, it has 6. And we see here that hydrogen and oxygen can share 1 pair of electrons here. So between this hydrogen atom and oxygen, they're sharing 1 pair of electrons. And then you'll notice that oxygen still has that one unpaired electron up at the top. So that means we need to bring in another hydrogen atom, just like we would do for our ionic bond when we wanted to make sure all of those electrons were bonded or satisfied to make sure that they had that full valence shell. So here in this case, we bring in another hydrogen atom, and it's going to share a pair of electrons there. Now between this hydrogen atom and oxygen, they're sharing one pair of electrons. So if we were to draw what their structural formula would look like, we have hydrogen, and it has a single bond here with oxygen. And then we have another single bond with the other hydrogen atom. Okay, so the chemical formula for this would be H2O. Congratulations, you just made water. So we have the 2 here, the subscript 2, to represent that we have 2 hydrogen atoms in the bond and 1 oxygen only. Now, this is where it gets a little tough. A lot of times students get confused. This is considered a single bond. So when you're trying to determine whether it's a single bond or a double bond or a triple bond, you really want to focus on 2 atoms at a time. So between these 2 atoms, our first hydrogen and our first oxygen, they're sharing one pair of electrons. So because they're sharing one pair, that's considered a single bond. And the same thing goes over here. We have this hydrogen atom bonding with the oxygen. So that's one pair of electrons being shared. So that is also a single bond. So what would a double bond look like? Well, let's take a look at our next example. We have oxygen. Again, it's part of group 6. Has 6 valence electrons. Sulfur is also part of group 6. So it has 6 valence electrons. And so they're going to share their 2 unpaired electrons between each other. So that's 1, and there's the second one. So here we have 2 atoms sharing 2 pairs of electrons. So that is considered a double bond. So in the structural formula, when you draw it, it would look like this. O for oxygen, 2 lines to represent the double bond, and then sulfur. The formula would be OS because we only have 1 oxygen atom and 1 sulfur. And again, this is considered a double bond. Okay. Now, our next example, we have nitrogen. Nitrogen is part of group 5. So it has 5 valence electrons. Now you'll notice that there are 3 unpaired valence electrons. So they'll form a bond here. They'll form a bond here. And then the last here. Now here we have 2 atoms sharing 3 electron pairs. So that is considered a triple bond. So when you're drawing the structural formula, it would look like this. Stay consistent. Chemical formula would just be N2 because you only have 2 atoms of nitrogen. And again, this would be a triple bond. And that's it.